Hello everyone, I am Sixun Huang from National Kaohsiung University of Science and Technology, Taiwan. Today, in this video, we will talk about heart-like feature, which is one of popular features used for object detection, especially for face detection. The outline of this lecture includes introduction about the origin of heart-like feature, response definition about the way to compute the heart-like feature, fast computation about how to speed up the computation of heart-like feature in a constant time. Heart-like features are derived from Hart wavelet functions proposed by Alfred Hart in 1909. They are firstly used in the computer vision area for object detection in 1998. They become well known since its use in real-time face detection by Viola and Jones in 2001. What is a heart-like feature? A heart-like feature is a response from a rectangle in the form of a heart-like prototype. In general, a heart-like prototype is composed of several black and white rectangular regions, and the size of black and white regions are equal. Pictures below show some kinds of heart-like prototypes. Different heart-like prototypes are used for extracting different types of features. For example, edge prototypes are used for extracting edge features. A heart-like feature can be expressed as a phi t of I and theta, where I is the input grid level image, theta is the rectangle configuration, LT is the coordinate of the left-top point, and WH is the rectangle width and height, and T is the selected heart-like prototype. The rectangle with heart-like prototype is called the heart-like rectangle, which consists of several black and white rectangles. Phi t of I and theta is defined as the difference between sum of pixel intensities in white rectangles and the net in black rectangles. There are three steps to compute phi t of I and theta. Firstly, sum up pixel intensities in white rectangles, and then sum up point intensities in black rectangles. Finally, calculate the difference between these two terms. Here shows an example of a heart-like rectangle with theta equal to 1134 and with this selected heart-like prototype. The response of this heart-like rectangle is sum of white points minus sum of black points. That is 15 minus 26 and equals to minus 11. However, computing heart-like features in this direct way is computational expensive. This is because time complexity of computing a heart-like feature is order W times H, and an effective descriptor is generally composed of thousands of heart-like features. This makes the heart-like features unsuitable for real-time application. To address this issue, a data structure called the integral image is used to speed up the computation of a heart-like feature, reducing the complexity from order W times H to constant time. What is integral image? II of xy, a point xy in integral image, is defined as intensity sum of points in rectangle taking 0, 0 as the left top point and xy as the right bottom point. The formal definition of II of xy can be expressed as this equation. This picture shows the integral image II resulting from the original image I. For example, II of 2, 3 in integral image is equal to sum of all points in this rectangle with dark mask, whose left top point is 0, 0, and the right bottom point is 2, 3. Accordingly, II of 2, 3 is equal to 7 plus A plus 5 plus A and equals to 28. The computation of integral image is beyond the scope of this video. You can refer to the other video called the integral image in our channel for detail. Using integral image, we can compute the sum of points in a rectangle in constant time. According to basic geometry, sum of points in gray rectangle in original image equals to sum over red rectangle minus sums in green and the blue rectangles, and finally plus the sum in yellow rectangle. The sum over points in these 4 rectangles are respectively equal to red, green, blue, and yellow points in integral image. Accordingly, sum of points in gray rectangle equals to red point minus green and blue points and plus yellow point in integral image. In other words, computing sum of points in any rectangle only needs 2 subtractions and 1 addition. For example, sum of points in the white rectangle equals to red point minus green and blue points and plus yellow point in integral image. It equals to 30 minus 10 minus 9 and plus 4 and equals to 50. Similarly, the sum of points in black rectangle equals to 16, 3 minus 30 minus 16 plus 9 and equals 26. As for this heart-like feature, since the terms for white and black rectangles can be computed in constant time using integral image, the complexity to compute phi t of I and theta is also a constant time operation. In this lecture, we detail the heart-like feature and the integral image for speeding up the computation of heart-like features. Thanks for your listening and have a nice day.